Okay, so today we're looking at areas enclosed by the y-axis. So our learning intention is to gain the knowledge in calculating the area bounded between the curve and the y-axis. We're going to be successful if we convert an equation making x the subject and then integrating with respect to y. Okay, so imagine we have a curve such as this, and we're going to find the area enclosed by a to b on the y-axis. So the first thing we have to do is we actually have to make that function in terms of x. So our y values are derived from our x values. And then we have to take the integral from b to a of the function of y dy. Now, anything on the right-hand side is going to be a positive area. Anything on the negative side of x is going to be a negative area. So we have to take the absolute of that. Let's do some examples. We want to find the area enclosed between the curve x equals y to the power of 3, the y-axis, and the lines y equals 1 and y equals 3. So it's really important to sketch a graph to remind you of the area that you're trying to calculate. Okay, so we're going to integrate between 3 to 1, and we want the function in terms of like x equals, and in this situation it already is x equals y cubed, and we're going to integrate that with respect to y. So it's going to be dy. So if I integrate that, it's going to be y to the power of 4 over 4 bounded by 3 and 1. Okay, so plugging that into a calculator, we're going to get basically 3 to the power of 4 over 4 minus a quarter, which is going to give you 20 squared units because you're calculating area. Okay. Here's another example. We want to find the area enclosed by the line y equals 2x plus 1. So there's the line. The y-axis and the lines y equals 3 and 4. So I drew a quick sketch. Okay. Now, I'm going to have to integrate from 4 to 3. A function that has to be in the format of x equals, right? So in this situation, I need to rearrange this. So y minus 1 equals 2x. So x equals y minus 1 over 2, which is the same as writing a half of y minus a half. And we're going to integrate that with respect to y. Okay, so if I square that, so I raise the power, becomes 2, a half divided by 2 should be a quarter. So we get a quarter y squared minus a half of y bounded by 4 and 3. Okay, so 4 squared is 16. 16 divided by 4 is 4. And a half of 4 is 2. And so 3 squared that's going to be 9 over 4 minus 3 over 2, 1.5. Okay, so that's 2. It's 3/4. So we get 5 over 4, or 1.25 squared units. Okay. Here's another example. We want to find the area between the curve of y equals log x, the y-axis, and y equals 2 and 4. Okay, so once again we're going to integrate from 4 to 2. I need this in terms of x equals. Okay, so this basically means if I do e to the y, e to the log x cancels out, leaving me x equals e to the y. Alright, so we've got e to the y in respect to y. Okay, so the integral of e to the y will still stay as e to the y from the boundary of 4 and 2. So I'll get e to the power of 4 minus e to the power of 2. And if I plug that in, e to the power of 4 minus e to the power of 2, I get 47.209099393 squared units. And let's do it to 3 significant figures. Okay, so when we're finding the area bounded by a curve on the y-axis, make sure that you rearrange your equation so that x equals something and integrate in respect to y. Okay, thank you.